We'll take a look at what information should be collected if you're troubleshooting a multi-cell DECT DBS-210 deployment. The first page you want to take a screenshot is going to be the home status page. On this page, we also want to verify that the DECT station, base station, has the latest firmware. As of the recording of this video, this is the latest firmware as far as if the base station is deployed with WebEx Calling. Also, you can see a history of most recent reboots, what the status is. Okay, next item we want to take a look at is extensions. These are going to be the actual DECT handsets. And again, we want to verify they have the latest firmware. In this case, they do. Also, the other item of consideration is the actual signal strength. Typically, if we start getting to negative 70 dBm or higher number, like negative 72, 73, so forth, that's an area where loss of quality and or connection is a possibility as you're getting up in those higher 70 numbers. So definitely, if you're running into issues, it could be an issue where the signal strength is not strong enough from the base station to the handset and vice versa. So just keep that in consideration when troubleshooting. Okay, so the next thing we're going to take a picture or screenshot of extensions. And the next one we want to look at is going to be under the multi-cell section. Okay, so we want to take a screenshot of this multi-cell configuration screen right here. And then, depending on your resolution, you may need to scroll down, kind of what I'm doing, and taking another screenshot of this. So this is going to show that the primary unit is this top unit right here. And the unit we're currently on is a subordinate unit, so it's not acting as a primary unit. It does show it's locked, which is a good indication. It also has very strong signal strength, negative 24 dBm. And I am testing this in a lab environment. If you have this deployed in a site, you're definitely, and it's spread out over an area, you're definitely not going to see a signal strength of negative 24 dBm. Generally, it's going to be much, much higher than that, but you do want to be careful not to get into the negative 70s and so forth. Because once you start getting in the 70s, you're kind of at the edge of where functionality, is possible. Meaning if it's a warehouse or other type of area where there may be different objects, they may be attenuating the signal based upon inventory coming in and out. Or if it's a space where there's people coming in and out, and you're already at the very edge of the workable signal strength, this can be causing disruptions to your multi-cell deployment. So just be aware. Again, if you're getting to negative 70 or above, negative 72, negative 73, so forth and so on, then this potentially could be an issue why you're seeing issues with the multi-cell deployment. Okay, so let's take a look at the next thing we want to focus on. So it's going to be under diagnostics. So what we want to take a look at under diagnostics would be logging. And then what we want to do here is we want to enable RSX internal tracing. So we want to enable this. We want to enable all the different items I'm check marking the boxes for here. Okay. And then at the very bottom, we want to go ahead and save this. And this is going to basically enable debug level logging. Okay, and then we also, I need to go back to the multi-cell. We also need to enable logging on multi-cell for debug level. See where it says multi-cell debug level? We want to go ahead and do both for here. We want to go and we want to save. Okay, this will take 3 seconds, okay. Okay, so now we have multi-cell debug logging enabled. We also have the general debug logging enabled, which is under diagnostics. And normally what I would suggest is let it run, with this debug now enabled, the normal debug, this general debug, diagnostics, what I'm calling. You would always leverage this for either single cell or multi-cell, but in this case, since we're focused on multi-cell, we would, on top of this, also have the multi-cell debug enabled. And I'll go back there just for a moment so we can take a look at that, which is this multi-cell debug both. And then basically what we would do is when the problem occurs, we would want to make sure that we're under diagnostics right after the issue event occurs, and then we want to go ahead and do all base stations for downloading traces. There's one other thing we need to look at. In a multi-cell deployment, you will have multiple base stations. So we want to go to the next base station we have, and we want to make sure the same settings are being applied regarding the debug logging. So we're going to go to multi-cell, and then we're going to go ahead and, okay, so this one's already multi-cell debugging. So you would want to verify this because it is possible, in my case this was left from before, some of the information does get propagated, other information may not, so you would want to verify. In my case I only have 2 DBS-210s in my lab multi-cell configuration. If you have multiple units, you would want to log into the respective units you're troubleshooting to make sure it's enabled for debugging multi-cell. And then we want to go under diagnostics. We want to go to logging. Okay, so this information has gotten propagated. Okay, so the other stuff we want to look at is configuration. We want to go ahead and export this. So where it says configuration, we want to go ahead and export that. There'll be an XML file, settings. And then the next thing we want to take a look at is going to be syslog. So we want to go ahead and also export this. So go ahead and export this. And again, this is assuming that the issue event just occurred. We want to go ahead and capture, export this information right after that. We want to go to SIP log, and we want to go ahead and export this. Okay. And then we want to go ahead and under diagnostics, we want to go ahead and all base stations, download traces from all base stations. So we want to generate that. This will take a number of minutes. The more base stations you have, the longer this may take. If you're having difficulties and this part is not, it's taking too long or it's not able to grab all of the base stations, you may have a scenario where islands are being formed. The base stations have 2 mechanisms they use for communicating in multi-cell. They use IGMP snooping version 1 multicast traffic across the RJ45 Ethernet cable, basically the LAN the switches are plugged into for general management. I'm just going to put test, but you would obviously want to put the description of what is the issue event that we're troubleshooting. So in any case, so this is going to download here a all basis traces. There is a small Wireshark capture in it. We'll take a look at it in a few moments here. But what could be occurring is you could have a scenario where islands are being formed. So you'll have a few base stations that kind of see each other and are kind of operating in a mini island, if you will. Then you'll have another potential few base stations on another part of your facility. They're part of the same VLAN, but they're also kind of operating in another island. And in that case, you would want to go to the respective base stations, kind of do what I'm doing here to try to capture as much debug level information and the other different types of logs I'm showing. So in that type of scenario, you may want to use current base station if you're noticing that all base stations is taking too long and or not able to capture the needed information. Okay, so we want to go and take a look at, you will get these pop-ups where you have to re-log in every so often. So we want to go to this general statistics and we want to take screenshots. So this is showing the statistics for the DECT portion for the RF. In United States, it is using 1920 to 1930 megahertz frequency. This is a frequency that is allocated specifically for this DECT equipment usage. Be aware if the venue is a convention center or a stadium or where you have multiple different parties potentially using equipment with the same DECT technology, and it's a high dense type of deployment, there may need to be considerations, and there typically is if it's like a concert or a sporting event. Typically there'll be a team on site that does RF management or spectrum allocation management, and you would want to make sure if you're temporarily going on site with equipment that's using the 1920 to 1930 megahertz that ahead of time you would work with a team so there's no issues if it's such a venue. But generally I've not seen with this specific equipment, with the DECT equipment, that being an issue generally speaking, but just be aware there is also pro audio equipment for certain audio microphones, as I mentioned. If it's a professional sporting event, if it's a concert where there may be equipment in that arena, they may be using the same RF spectrum. Okay, so let's kind of go down here. So we want to take screenshots of all the different sections of this page. So typically what I'll do is I'll take screenshot, move down a little bit, take another screenshot, move down a little bit, take another screenshot, move down a little bit, and take then the last screenshot. And this is all information that if you're working with Cisco TAC, they're going to request. So this is really to kind of help with that information. What information do you need to collect if you're running into issues? And this is kind of the information that you really want to collect right after the issue event. Under statistics, we want to click on export. So let's go to export statistics. We wouldn't, for this deployment, I don't have any repeaters, so that is not a consideration. Dial plans, if we're troubleshooting really multi-cell deployment where there's issues of base stations or DECT phones not being able to make connections with different parts of the multi-cell, so the dial plan would not be a consideration. Okay, call progress tones, not a consideration. Okay. So LAN sync is something that's interesting. So the base stations by default, specifically if you're deploying this with WebEx calling, by default, they're going to use something called RF sync or radio sync. So it's going to use basically the radio frequency for doing clock synchronization. And that is something you really don't have control over. So in WebEx Control Hub, if you go, you will see there's really no options for the RF adjustment as far as do you want to use the RF sync or do you want to actually use the LAN sync, what they're calling here IEEE 1588 LAN synchronization settings. This is also known as PTP v2 protocol. So let me really quickly go over here to WebEx Calling. We're going to go ahead and authenticate here. Okay, we're going to go under calling. Okay, we're going to go under features. Okay, we're going to go under DECT network. And then the one we are looking at right now is the My DBS-210 for site 1. Okay, so you'll notice here there's not too much on the main landing page here. If I go under manage for the base stations, I have 2 in my lab, DBS-210s. And then we'll see this first base station, and again, some of the information I will be blurring for obvious reasons, like the MAC address and other such information. So on this first base station, I have 2 DECT phones registered. So on this page, there's really no settings offered. If I click on this greater than symbol, it shows the 2 DECT handsets I've registered. One is going to John Smith, the other one is going to user 1. And then the next option it offers is view status. It shows it's registered. But there's really no additional features at this point of time when I'm recording this video as far as making any type of adjustments. It's designed to be really simple to deploy this. So getting back to this synchronization concept. So if you're using WebEx calling, it will be the RF clock sync. So it's going to be using wireless. As I mentioned below, if the signal strength between your base stations is hitting -70 or above, as you start climbing above into, -72, -73, and climbing higher and higher, it is becoming an area where it's right at the ragged edge. And as I mentioned, if there's merchandising, if this is a warehouse, a retail store, or some type of venue where there's potentially a lot of people, times like airports, etc., the attenuation levels can be changing at a level where if you're at the ragged edge of the signal string, that can be causing the clock sync to not function correctly because there's not enough signal there for the base stations to be able to see the clock sync. So this is a scenario where you may need to consider using the IEEE 1588 for clock synchronization. It is not offered on WebEx calling. As far as this is not something you can configure yourself. You would need to open up a case with Cisco TAC and work with them to determine if this is a direction you'd want to head towards, and then they would have to do kind of a custom configuration on the back end. One general word of caution, and this is not specific to the DECT product that I'm showing here, but just general, so this applies to pro audio, pro video, industrial, networking, anything, and also a lot of different scientific applications use PTP v2 IEEE 1588. There is special considerations for the network infrastructure, specifically the switches. Not all switches may not be able to support this traffic correctly. There's timing considerations, delay, jitter, packet loss. And often those timing considerations can be very, very tight. For example, in the pro audio industry, we're typically dealing with microseconds, not milliseconds, but microseconds. And there's other industries we may be dealing with nanoseconds. And those are very hard numbers to attain. Especially in most scenarios, you'll have multi-switch hops that the traffic needs to traverse. So just be aware this is available on the DBS-210 base stations where you can do the clock synchronization over the physical Ethernet network, but there is additional considerations to be made also from a QoS standpoint. The traffic for EF, expedited forwarding, for PTP v2 does need to be expedited forwarding, strict priority, basically the highest level priority queue for it to have minimum effect as far as latency, jitter, and packet loss. Okay, so let's move on here. Let's see if there's anything else we need to consider. Okay, so let's take a look here. One item that may come up as a question is if I'm deploying this on WebEx calling, can I configure static IP addresses? And the answer is no. It is only DHCP, and that's kind of what I'm showing here is DHCP. The other item is going to be if the issue that you're running into is more sporadic, you may need to point the respective base stations to a syslog server. So in that case, what you would basically need to do is where it says for syslog server IP address, you would basically type in the IP address of your syslog server. You would leave the port, the standard port 514, and then you would enable upload of syslog. The syslog level, you would want to go in and put debug level. Normally, most environments, you would not be doing TLS security with syslog. And then you would go ahead and apply this towards the bottom here. So you'd hit save. And then you would want to make sure that this is actually, because you should immediately start seeing messages being sent from the base stations over to the syslog server. And what I would suggest is, I wouldn't go, put a bunch of base stations pointing to the same syslog server unless the syslog server has some type of mechanism to parse the information. I would recommend if you have multiple base stations, if you can point each base station to a dedicated syslog server, it can be just a VM. If you have type 2 hypervisor on your PC, you can just launch multiple instances of VMs and just have one going to each base station to a separate syslog server. The goal is to make parsing information a little bit easier, and also if there's any connectivity issues between different base stations and different points of network. Also, we kind of want to understand if, what the patterns look like. Okay, so let me see if there's anything else of consideration here that we need to look at. Okay. So what we're going to do here next in a few moments is we're going to take a look at what has been downloaded, just as far as kind of a visual validation to make sure it has information that you can pass on to Cisco TAC. This is information we have collected from the base station. Obviously, I'm not showing any screenshots. Throughout the video, I did mention what pages we want to do screenshots of. So the assumption is you will go ahead and take screenshots of those respective pages. But as far as what has been actually downloaded from the base station, so we have our settings XML file. And I'll just do a visual to make sure there's actually data here. 19 kilobytes, fine. SIP debug.txt, 25 kilobytes, fine. Stat, this is a lab unit, so there's not much activity as far as phone calls go, so that's fine, 3 kilobytes. And syslog, 50 kilobytes, that's fine. The file typically of interest, so all of these are important, but typically the file of interest is going to be the all basis traces. So I'm going to use 7-zip here to unzip that. We're going to go inside this. This is going to show the MAC addresses here of the respective base stations. So this is where you would type in what the issue was, where we had the dialog box. I just put here test because this is just a lab unit. Requested base stations. So this is showing some information here. So let me see if I can adjust this a little bit. Okay. So in my case, I only have 2 base stations in my lab. So one of them is .82, the other one is .70. I'm going to go ahead and blur out the MAC address information here, but I'm just kind of highlighting that, so it also shows the MAC addresses. There was 0 base stations with invalid IP addresses in multi-cell. That's exactly what you should see. There was 0 base stations with duplicate IP addresses in multi-cell. There were 0 requested traces that was not delivered. So this is all positive. As far as all this stuff we're seeing, this is a fully functioning multi-cell deployment, no issues whatsoever. One message you may see on the web GUI of the actual base station when you log in is you sometimes may get a red message on the top left corner. They'll pop up, they'll say invalid IP address, or excuse me, let me rephrase that. It'll say duplicate IP address. Even though technically, if you look at the Wireshark captures, you will have no duplicate IP addresses. And normally what I found, if that pops up, there's an issue with the communication with the multi-cell base stations. And what happens is, normally in a multi-cell base station, when it's first brought up, you have the first unit, you bring up the first DBS-210, then you bring up the second DBS-210, so on and so forth. There will be an election, and one becomes kind of the managing base station for the entire multi-cell deployment. So if islands form, then what will happen is in each island, there'll be a base station that becomes now the managing base station. And when they see traffic from each other, there'll be a confusion. Why are multiple base stations proclaiming they're the managing base station. And that's where a duplicate IP address message may be seen, even though technically from a packetization standpoint, as far as if you look at the source IP addresses, there's no duplicate IP addresses. It's just within a multicast group, there'll be multiple base stations proclaiming they're the managing base station. So just be aware, it might be a little bit misleading if you see the message. This just has some general information here. So this is just kind of general information, kind of under the hood, what it looks like. Generally there, that's an area typically not a focus. I'll take a quick peek, but you want to go under Traces MAC, and we just want to make sure all of this information here, we are seeing contents within the actual files. 14 kilobytes, 25 kilobytes, so on and so forth. So as we go down this list, you'll see all of these files. And the reason we most likely have 0 on the SIP log right here is the 2 base stations that I have deployed, only one of them has the SIP phones registered. Since I have everything within a very close vicinity, it's kind of, depending if I had one offline, then they both kind of went to the other one and vice versa. So if it's not, there's no DECT handsets registered to one base station, then this 0 in a SIP log would not be too surprising. But generally speaking, other than that, the other files should have information in them. So if you end up with a situation where you're getting 0s or 1s here, then something is not correct, and you want to go ahead and try to regenerate the traces, and just select the one unit. Don't do all base stations, because there may be communication issues between the base stations, and that's preventing the information from getting gathered. As I mentioned, there is a actual Wireshark capture that the unit itself does go ahead and perform. So we'll go ahead and open up the Wireshark capture here really quickly and take a look at it. So what we're going to really focus on is going to be the multicast portion. And so we can go ahead and go to statistics, and then if we go down to the UDP multicast streams, and then let me actually just resize this a little bit here. So this is going to be basic, the multicast group that they're using for communications between each other for the multi-cell. 224.57.14.167. And you'll notice that both base stations, DBS-210s, are part of this. So this will be a pattern that if you're troubleshooting, we want to make sure the multicast that's using IGMP snooping version 1, that is functioning correctly. There is a possibility with certain switches they may need special configurations to properly be able to propagate the IGMP snooping traffic to the respective ports. One of the switches, or one of the series of switches, is Meraki. So if you look at the DECT deployment guide that's offered online, it does have mention of what needs to be done under Merakis to allow the propagation of IGMP snooping version 1 traffic. So just be aware, if you're running into issues, you definitely want to take a look at that and see potentially if that is an issue. So what we're going to do here is we're going to quickly take a look at the traffic. So let me go ahead and make an adjustment here. So we want to go ahead and let me just remove this. Okay, and then let me go ahead and trim this down. Okay, so basically what we're doing here is we're just looking at the traffic that's coming from both the base stations. So what you'll notice is the packet count is reasonably low. We're not dealing with crazy amounts of packets per second. If this was pro audio, pro video, or other areas where the traffic is very heavy, if you will, from a multicast standpoint, the traffic volumes would be substantially more. In this case, we're focused on the management traffic. between the base stations. And it's very minimal, but obviously as you add more base stations, this will increase. But still, I would classify it as lightweight from a multicast standpoint. Generally speaking, if we look at other applications use multicast, pro audio, pro video, in those scenarios we're talking about thousands of packets per second that they leverage, because the multicast is not only used from a management and discovery standpoint and a clock synchronization standpoint with those applications, but also often it is used for the delivery of the audio and video. And that will vary depending which specific protocol they're using. Are they using AES-67, QLAN, etc., etc.? Coming back to this, as you notice, it is fairly lightweight, and the reason I point that out is if you have a situation where for some reason the IGMP snooping mechanism on the respective switches you're using cannot properly support IGMP snooping version 1, which this is using, then one option to consider is turning off IGMP snooping on those respective switches for the VLAN this is part of. This assumes there's nothing else in the VLAN that is multicast that might cause a lot of traffic generation. So that's one assumption. The second assumption is, does that specific make and model switch allow you to do per VLAN configuration of IGMP snooping? Most manageable switches nowadays do offer a per VLAN configuration ability of the IGMP snooping as far as turning it off. There are still some switches that do not allow that. If you have IGMP snooping configured, you do need to make sure in that respective VLAN that one of the switches has query enabled, and that's going to be sending out query messages. It varies from switch make and model what the query interval is, but generally what I've found is there'll be anywhere from 60 seconds to maybe 120 seconds, somewhere in that range. I've not noticed anything as of yet as far as a specific requirement for the query interval when it comes to this specific application, the DECT DBS-210s. In most applications, I've not, as far as multicast, not found that to be, most manufacturers don't specify that, but you always want to take a look at the documentation for deployment and any release notes, because, definitely there'll be certain scenarios where there may be special requirements. So let's see if there's anything else of consideration that we need to look at here. So we know that multicast traffic is very lightweight here, so if you do need to disable IGMP snooping, that should not be an issue itself for this specific application. If you're having issues, I would first start off with one switch and seeing if you can get a stable configuration on one switch with a multi-cell. So you have one switch, you'll deploy the first base station, then go in and deploy the second base station, get a few handsets registered and let it run for a period of time and just see if there's any issues. If then you add a third base station to a second switch where the traffic, the multicast traffic, has to traverse between the switches and you're seeing issues, there may be some manual configuration for M port you may need to do on the link between the switches. Generally speaking, on the Cisco switches, I've not found that you have to configure M port. Generally, that is something that's automatically detected by the operating system in the switch, and it knows how to automatically configure the proper settings for M port. On other switches, like some of the HP switches I've seen, sometimes you do have to configure M port. I'm not sure about currently, as of right now, if that's changed or not. So it may be hit and miss depending on the make and model switch you have, and that's where I suggest if you're having issues, go ahead and first focus on one single switch, get two base stations deployed on it as minimum, so you can do a proof of concept. Does the multi-cell function correctly on the one switch, two base stations, and let it run for a period of time. When I say period of time, I'll probably give it at least half hour or so, and then just do some site survey with the actual handsets, and try to keep the base stations separated far enough where the handset is forced to to basically hop from one base station to the next base station. That would be a key component, just to make sure that handoff is elegantly occurring between base station 1 and base station 2. You may need a larger space. The DECT RF signal 1920 to 1930 megahertz does actually a really good job as far as reach, especially if you compare it to Wi-Fi. So that might be potentially something that if you have a smaller, like a lab area, may not be easy to do. If you're trying to do that, you may want to see different ways of attenuating the signal, the RF signal, by creating different type of boxes. It could be some type of denser material, metal or concrete type of dense material. You can also try Faraday material. So far, I've not seen Faraday material be as potent with the 1920 to 1930 megahertz RF energy when compared to if you were to do the same thing with Wi-Fi 2.4 and 5 gigahertz. So that may be an area that may be a little bit more tricky to do some type of testing. And then let's see what else we can look at from a Wireshark standpoint. So one of the things I typically like to do if I'm troubleshooting that is something that is going on with multicast is to see if there's any activity from IGMP snooping. In this case, I don't have any IGMP snooping enabled. It's a very basic setup. I have both of my base stations on one switch, but definitely if it's a larger deployment, most likely you would want to enable IGMP snooping and just make sure one switch is configured as querier. And then just make sure the query messages are able to reach all of the respective switches, and then also the respective switch ports where the base stations are, the multicast DBS-210 base stations. And what should happen is when the query, general query message goes out from the querier, within 10 seconds, the base station should reply back with the multicast groups it wants to be part of. In this case, the scenario I'm showing, it will be just one multicast group we're concerned about. Okay, and I mentioned this briefly. A key document to take a look at is the Cisco IP DECT Phone 6800 Deployment Guide. And here specifically, what I wanted to point out was the comment I made about Meraki switches. Multi-cell requires that IGMP snooping be disabled on Meraki switches, so just be aware of that. There is also propagation to propagate. So there's one other setting. I don't know if it gets mentioned in this document, but there is one more setting where once you disable the IGMP snooping, there's, I think it's a checkbox item where you would tell it to propagate all multicast traffic. The only thing you want to be careful is historically the IGMP snooping configuration Meraki has been global. It's not been per VLAN. So I don't know as of the recording of this video if anything's been updated. And I don't know at this point of time if that's changed or not. So just be careful if you have other multicast applications that are relying on IGMP snooping, or they're heavy-duty multicast application, meaning they're doing thousands and thousands of packets per second from each node, then you definitely would not want to disable IGMP snooping. That would be an issue because the other applications would be flooding the network. So this is where in the pre-sales phase, you definitely want to take a look at understanding what do you currently have on the network, and if it's a switch that has limitations supporting IGMP snooping version 1, that you understand what options you have. Can you disable a per VLAN based IGMP snooping? And if not, you know, what other alternatives do you have as far as that goes? Some other notable mentions is currently DECT DBS-210s regarding the multi-cell do not support routed layer 3 multicast networks, meaning if you're going to be running like PIM sparse mode, and let's say you have multiple buildings or you have multiple floors in a very large building, and each floor is a different subnet, You would not be able to deploy the multi-cell between those and have it act as one large multi-cell. Management traffic that I was mentioning, the multicast traffic that's using for managing and for the DECT base stations to talk to each other, that multicast traffic currently does not support a layer 3 routed multicast network such as PIM sparse mode. Okay, so this is the range multicast traffic for multi-cell uses. So it'll be from 224.100 up to 225.1.00 for data synchronization. So that's kind of the management, if you will, of the multi-cell. And if we go back at the Wireshark capture we took, and we compare that, we'll notice the one that the base station multi-cell that I have deployed in my lab, it's using 224.57.14.167. So that kind of falls right somewhere in the middle of here. Okay, this kind of repeats the layer 3, so not being supported. So base stations using multicast within the same multi-cell must be in the same broadcast domain and be provisioned with the same layer 3 subnet. This kind of reinforces this statement right here on the bottom. Multi-cell multicast across a router layer 3 multicast network is not currently supported. These are kind of both tied to the hip, those two statements. Yeah, so this multi-cell can utilize multicast or peer-to-peer unicast for data sync. However, primary base station with peer-to-peer configured has no redundancy. Yeah, so generally these are settings not offered if this is being deployed with WebEx calling. So one thing I should mention is this platform is also supported with CUCM. So if you're deploying this with CUCM, number one, make sure you have the latest firmware, 5.1.2, or whatever the latest firmware is when you watch this video. So that's number one. Make sure all the base stations have been updated. Also, the DECT handsets have been updated. I have a video on how to do the firmware updates. Note the base station firmware updates go kind of quick. They're somewhere between 4 to 8 minutes for the firmware to be ingested, another 2 minutes for it to write and reboot. However, the DECT handsets are a different situation. Those can take anywhere from, the numbers I've been seeing when I've done it is anywhere from 35 minutes being the fast times all the way up to like an hour and 15 minutes being kind of like on the slow side. So if you're doing firmware updates, please make sure that the handsets are in the cradle and are being charged. That's very critical to make sure the battery, they don't go offline if the battery's discharged. Okay, and then they just make a mention here for class 2 PoE. The other is going to be the RF coverage. So let me see if I can. So I mentioned earlier, if we start getting into -70 or higher dBm, we're getting into an area where the signal strength is at the ragged edge. And if it's an environment where merchandise, people, or other elements may be introduced where it causes attenuation to go up, meaning the signal now is going to be less and less and less because now there's something between the two base stations. So it is critical to make sure for the radio frequency clock synchronization that there's at least 20% of headroom between the units to make sure when there's anything being introduced here to minimize the risk of losing signal, because otherwise that can affect the multi-cell deployment and yield some very unusual symptoms. And so this would be kind of the concept, almost like a cell type of situation. So from the very first to the very last base station, we want to make sure there's some type of path we can get to. Even though, let's say you have a situation, not everything can be overlapped in this type of illustration we're showing here, kind of more of a educational type illustration where it may be more kind of, you have one base station here, another base station here, another base station here, and then another base station here. So it would kind of have to go in a roundabout way. As long as from the first to the last one there is a pathway, that is the key point. If you can get redundant pathways like we have here, which is a full mesh, that would be ideal, but in a lot of cases, you know, it's not going to be 100% mesh on between all the different units in that pattern. So in this document, they do talk about different scenarios. This is the air sync or RF sync, which I was referencing, so they can roam from one cell to the next cell. In most environments, this is what the end user would kind of expect to be able to do. So just, be aware that if you are running into issues, I would start off first with one switch, two base stations, one switch. Do roaming testing with that to make sure that part works. Because if that part doesn't work and you're having issues, we should not be expanding it any further. We need to figure out, okay, what is happening? Is there an issue with the air sync, the RF sync, if you will? Is there an issue with the multicast? Is there an issue if this is deployed in WebEx calling as far as the communication from the base stations up to the cloud? Is there some type of interference traffic on the network? High elevated levels of broadcast, ARPs, or other multicast traffic, elevated levels, sort of like pro audio video that these base stations are being bombarded by. Is there an issue from a 1920 to 1930 RF spectrum? As I mentioned, in most environments, this would not be an issue because this frequency is really kind of focused on in the US for DECT phones. The only exception to that might be if this is being used in a stadium, convention center, or some type of arena where there may be concerts, a lot of different types of meetings where you have folks coming in with pro audio equipment. There is pro audio equipment that they use the 1920 to 1930 spectrum, our spectrum for the pro audio equipment. In those types of venues, typically there'll be RF management team where you need to register what you're using and where you're going to be at with the respective team, and then they manage the RF spectrum for that actual event. Okay, so let's kind of go down here to see if there's anything else in consideration. Okay, so this also shows where we have two switches, and then we have the same subnet, and of course subnet being referred to same VLAN, and then the air sync is working, or the RF clock sync, which I like to refer, that's working. So user that's initially on the first base station left side, they can roam over to the other part of the building, and then they'll gracefully roam over to the second base station with their calls. And as mentioned, on the LAN side, it is using multicast and IGMP snooping v1. Okay, so this shows another scenario here. Bases don't overlap and use a single switch in a single physical location. Conditions: LAN sync is used to allow both base stations to form primary, secondary in one multi-cell. Maximum of 254 base stations are supported. Same VLAN, same subnet, same broadcast domain, same switch, multicast allowed, IGMP snooping v1 allowed. Base stations are not within air reach from each other. So yeah, so in this case, as far as roaming goes, obviously because there'll be dead area here in the middle from RF spectrum, that is not going to be passable. It's going to basically drop. So once it gets at the edge here, the call will drop, and then the phone, once it's in the secondary cell, will re-register, and then they'll basically need to make a new call if they were talking to somebody. So this is not ideal. It is a possible scenario. Just be aware for the LAN sync to be used. If you're doing this WebEx calling, this is not something that's offered. You would need to contact Cisco TAC and work with them and see what is possible, because in Control Hub, at least at the recording of this video, there's no options being offered. If this is with CUCM, then obviously you have full access to do what you need to do from a configuration standpoint, and you would want to look at the admin guide and also look at this guide and just do some proof of concept testing to make sure that the PTP v2 IEEE 1588 packets are having no issues of being propagated between the different switches. As I mentioned, there are additional considerations if you're headed in that direction. You do need to make sure QoS is done correctly, because the timings do tend to be very tight for applications that use PTP v2. Okay, so this is another scenario here. We have one switch, however, we have the two base stations that have a gap between each other. So multi-cells formed, a DECT lock done over LAN, so there's only one primary, and then the roaming is not possible because there's a gap here in the RF coverage between the cells. Okay, so this scenario right here, number 4, bases do not overlap. Use of multiple switches, and switches are in a single physical location or multiple physical locations. Okay, so we're using again LAN sync IEEE 1588 to allow both base stations to form primary, secondary, and one multi-cell. Maximum of 254 bases are supported. Same VLAN, same subnet, same broadcast domain, separate switches, multicast is allowed, IGMP snooping V1 is allowed. Base stations are not within air reach from each other. LAN sync is used, IEEE 1588, so special consideration for this right here again. Okay, so this case, 2 buildings, so this could be a campus or it could be a convention center, something larger space, and we know the roaming is not possible. We have a gap within our coverage, and we also know, as I mentioned, IEEE 1588 or PTP v2 needs to be used. Again, special considerations from a network switching standpoint and QoS standpoint. Timing is going to be really critical. So as you have more switch hops, this is where you may be limited from a timing standpoint as far as it's able to meet the needed latency, jitter, and packet loss. And why QoS, strict priority QoS, is very critical. Okay, so handsets are not able to roam from one base station to another while on a call. Handsets will be able to move from one location to another, but not in roaming. Handsets can re-register from one base station to another. Handsets can register to any base station. DECT lock done over LAN. So this is the IEEE 1588 PTP v2 protocol. So there is only one primary. Okay. Okay, so let's take a look at best practices here. Planning is a single most important aspect of DECT multi-cell. While planning is sure to consider. Okay, so yeah, so I would kind of treat this very similar if you've done any deployments with the Wi-Fi or wireless, if you will. If you've done anything like airports, stadiums, campuses, etc., etc. So plan to have a fully meshed topology. So this will be ideal. As I mentioned, often there'll be areas, legs, if you will, where there's only one link as far as the RF clock sync goes. But if you can do full mesh, that would be ideal. Each base station should overlap with other 2 base stations by at least 20% for air sync. Kind of the diagram we looked at earlier. This will provide you with redundancy and fast failover. Yeah, so that is true. So if we have a leg that only has one link for the air sync and something happens to the one RF link, let's say a truck comes in, there's construction, or there's something else going on, let's say there's fencing put up for some type of special event or something of that nature, and suddenly that attenuates the signal to a level where it is unpredictable performance, and that can cause a lot of havoc. So yeah, so just this one, yeah, definitely a critical element to consider. Bullet point 1. So it uses a single VLAN subnet. Multiple subnets are not supported since multicast packets have a TTL1, hence won't traverse. Okay. Yeah, so as of right now, just be aware this is designed to be deployed within a single VLAN. So if you do have multiple VLANs, this needs to be deployed on. So that would then be treated as separate DECT networks, if you will. So this is where in the pre-sale stage, you should definitely work with like a Cisco partner solution architect, and just to kind of hash out, what makes sense. And also to, risk management in IT is very critical. What is the risk of the type of configuration you're doing if different scenarios, would happen? So that's kind of a key component when, designing, especially with the wireless networks. We're not only talking about the wired, but also there's RF considerations. Okay, if the above aspects are not possible and radio overlap is not an option, then you can use a LAN sync as long as all the base stations can communicate with each other over multicast. So the base can be configured to use TLS for signaling, SRTP for medium. We recommend use both. Okay, so for WebEx calling, this is something that, you know, it's already pre-configured, so it's not something you would be touching. When it comes to CUCM, be aware that currently the way this is deployed with CUCM as of the recording of this video, it is deployed as a third-party SIP device advanced, meaning there's quite a lot of limitations, what it can and cannot support. Take a look at, there is a chapter in the admin guide that talks to deployment, but what you'll find is it's a very basic device when it comes to deploying with CUCM. It's treated as a third-party SIP device advanced. The word advanced can be misleading. All that really means is you can have multiple line appearances up to 8. So when you're adding a third-party SIP device to CUCM and you need more than one line appearance, then you would select third-party SIP device advanced. That gives you a capability of going up to 8 line appearances, and that's kind of what this uses. But as far as a lot of features that you would historically be accustomed to with native enterprise phones for CUCM, currently, as the recording this video, this really acts as a third-party SIP device, so it has very minimal capability with CUCM at this point of time. Okay, it says bases send a keep alive message to other bases every 30 seconds after missing 2 keep alives, and the base can't find its primary, it will go into search modes. Yeah, so this is where you may see, if I talk about this from a general multicast troubleshooting, not only this, but pretty much any larger scale multicast application or device deployment you may be doing, this is where you'll see things kind of change over time as you're looking every 30 seconds or every minute. And this is where islands form, where things appear at times, disappear at times, etc., etc. So if you're seeing oddities like that, if possible, my suggestion is scale everything down to one switch during a maintenance window. So we're just focused on one switch, you know, with at least 2 base stations. Can we get stability with that? If we can get stability with that, then let's expand. Let's add a second switch, and then whatever base stations it has, can we get stability of that? If you boil everything down to one switch and you're still not getting stability, then boil it down to one base station. Can we get stability? If we still can't get stability one base station, and when I say stability, you may need to give it like 10, 15 minutes or so as a minimum to see if it will get stable. If you're down to one base station, you gave it 10 to 15 minutes, and you're still seeing instability or error messages, but there's no evidence from a networking standpoint. If you do some Wireshark captures, there's anything odd is happening. What I would do then is I would factor reset that base station. I have a video I've created on the factor resetting. It's fairly easy, assuming you can get to the base station. And the reason I make this statement, if this is deployed in a larger facility like a stadium, airport, etc., etc., it may be hung quite high up, so it may not be easy to get to as making a sound here from a lab troubleshooting standpoint. But the goal would be, if we're down to one base station and it's still not behaving as it should, let's factor reset it. Bottom right corner, there's a small button, paper clip, press it down for more than 10 seconds. I like to do 15 seconds to give myself a couple extra buffer seconds just to make sure everything looks good. And if you look at the video I've created on factor resetting the base station, you'll see there's a specific sequence of events that happen with the LED light on the base station. If you view the video, you'll see exactly what I'm talking about. But you want to make sure that that is happening as you're pressing it down. And I know outdoors, if you're on a hoist or a ladder or something, it can be quite difficult to visually see that and get a paper clip in it and hold it down, etc. So in any case, so let's see, a handset associated with an island which lose connection to its primary will also go into search mode unless the handset is on an active call. then in this case, the call is kept until it ends. Okay. Yeah, so this is something definitely to consider, this last or second last bullet right here. The terminology islands is very commonly used for multicast applications when you're troubleshooting and trying to figure out what's going on, because that is a very common symptom. And when I say that, again, it's not specific to this product or this technology. It's comprehensive. It doesn't matter if it's pro audio, pro video, scientific, industrial, or other special applications that may be using multicast and or PTP v2 and or other such applications that leverage multicast technology. IGMP v1 support in LAN is required for multi-cell to be able to form. Yeah, so in this case, it is assumed if you're running multicast applications, by default you would run IGMP snooping. In an effort, you can prune the multicast traffic for not being propagated to switch ports. Why this statement is made, so you have good control. If you're having issues with IGMP snooping on the respective switches you have, and there's no other multicast application on there, and when I say that, really meaning something that's heavy duty, that's pumping a lot of packets, if it's lightweight, kind of what this product is from a multicast standpoint, then you definitely can try turning off IGMP snooping and running without IGMP snooping. Just see if you get better results if you're suspecting there's some type of limitation where the switch or the switches may have issues with IGMP snooping version 1, which is what this product uses. So that is definitely a strategy. If you have other multicast applications and there's generating noticeable level of multicast traffic, then you do not want to turn off IGMP snooping, because that's just going to flood the network with all the other traffic, and you're going to have big problems. So this one, you just want to be careful, and this is where in the pre-sales stage, you probably want to do some proof of concept testing on your network if it's not clear, based upon the models of switches you have and other applications, what may be going on. Okay, so let's see if there's anything else here. Yeah, so DECT is using 1920 to 1930 megahertz for United States. Yeah, so it is different than cell phones, Wi-Fi, radios, Bluetooth. So those are different RF spectrums. The only comment I would make here regarding cell phones, in the United States, there is an allocation of GSM 1900. It is different than the 1920 to 1913 megahertz. In most communities, if you have a spectrum analyzer, you will see activity on GSM 1900. So it's right below the RF spectrum that this uses. I so far have not come across any instances where that's been a problem. But that is just something to be aware, just like anything else. If you do have access to a spectrum analyzer and you're doing a large deployment, you may do a spectrum sweep of that area and just see if there's anything of questionable. The other thing is also harmonics. So if this is a facility that's very close to high-powered equipment, if there's a shop doing welding, if there's something else, power substation or R&D lab, like aerospace R&D lab, etc., it is possible that equipment that is located in that area is generating harmonics and energy, RF energy. The second, third, fourth harmonic may be stepping on the 1920 to 19 megahertz RF spectrum. This is more theoretical, just to be aware. If you're doing heavy-duty troubleshooting and you're not able to figure out what's going on, just be aware with RF, it adds another variable to the whole troubleshooting domain. If you are going to use a spectrum analyzer, you do want to have one that has a very high sampling rate. It is kind of difficult to pick up on a spectrum analyzer. They mention here, ensure optimal use of the handsets and good coverage. Perform a site survey and mount the base station in a strategic location. Definitely, one strategy that's been used often is using different type of ladders and hoists. If it's going to be a larger deployment like a stadium, campus, airport, large warehousing, shipping yard, etc., etc. So you would want to try to get the base stations located and figure out what is the optimal positioning. The way I like to think about RF when it comes to RF, and this is not specific to DECT, but generally it's very similar if you ever had to deploy acoustics in a larger space like a stadium, a concert, a large meeting room. It's very important to have the proper positioning so the energy is being propagated to the target area. And this kind of has the same type of approach. Antennas here are omnidirectional that's used on DECT. There's no option for changing antennas that you may be accustomed to with something like the Wi-Fi equipment. So there's none of that type of optimization you can do. But as far as if there's any type of metallic objects nearby, that can cause shrouding and reflection, so be aware of that. Consider the effects of coverage by RF attenuation, that is correct, and RF interference during planning to have good coverage for the handsets, yeah. I did create a short video on how to put the handsets into site survey mode, so that's probably going to be your best tool for testing. And then just basically walking every couple feet, having a floor plan, and kind of documenting the RF signal kind of in a radio fashion, you know, every 5 feet or 10 feet or whatever you feel is enough resolution, but it won't take you too much time in the sense that it's within reason for whatever space you're covering. Radio considerations. Before planning the installation, the site survey should identify possible radio frequency attenuation objects in a coverage area. Okay, so this kind of covers some aspects. So yeah, so if we have a wall here, let's say this is a concrete wall. It's maybe like a shooting range or something that's industrial, and it's, you know, 2-foot concrete wall with rebar. You're not going to get any propagation of signal through this wall. So the only type of signal you may get is if there's any type of bouncing or refraction, kind of what they're showing here. So yeah, so these things definitely will cause dead zones back here in this back area. And this would be, again, same thing with acoustics. If this was a speaker and you're in this front area, you would be able to hear the high frequencies, mid frequencies, and the low frequencies. And as you get over here, you would start seeing the effect where the high frequencies definitely would be attenuated, very low levels. And then mid-range would be lost, and then back here, mainly it would be the low frequencies that you would be heard. If that, depending, you know, what the distances are and also what the background noise level is. Another way to look at is waves. There's videos you can look online where different folks have done analysis with like wave poles and stuff, and to see how the refraction works around an object. So very interesting. Same thing applies to RF. There is differences based upon the frequency, low frequency, mid frequency, high frequency, etc., what some of the characteristics are. So be aware. What I'm stating here is kind of general terms, but there are other more detailed items that can influence what the actual propagation characteristics are of the RF signal when it comes to different objects. Interference sources. The interference from other signals or the same network can make receiving signals weak. See, DECT can handle some interferences, and it uses different channels if available, for instance, from other signals identified and planned location-based. Okay, other DECT systems, some strong cell base stations, yeah. So as I mentioned, there's a GSM 1900 that is used in the U.S. This may vary if you're based in a different country. You may want to see what open source information there is. Different areas will have different agencies that cover. So in the U.S., it's FCC that covers the rules and regulations when it comes to RF usage for broadcasters and equipment like this, Wi-Fi, and other such equipment. So for your respective region, you'd want to see who the respective authority is and what information they have offered. And there's also other open source databases online you can check for. So let's see, DECT is not affected Bluetooth, Wi-Fi. Yeah, these are different frequencies. Most wireless cellular networks. The reason I say most is, as I mentioned, GSM 1900, but then also there could be other ones. If there is some type of issue with the radio on the cell tower and it's causing harmonics, and it's a really strong radio they have, that can also, in RF generally speaking, it's not specific to DECT, but generally speaking, that can introduce some issues. And that's where kind of a spectrum analyzer would kind of play a role. Okay, so this is a pretty good example here. So if we have here an object, again, concrete wall per se, this would definitely be poor, this area back here. We still may get some reflections if it bounces off something else where some signal may get, but generally, especially we're at the outer perimeter of the signal strength, this is some good distance away. Yeah, this would definitely be poor as far as signal strength goes. This is a pretty good listing right here. Different materials as far as attenuation levels. So wood, low, plastics, low. So for wood, doors, floors, and so on. Room partitions, so plastics, low. Tinted glass, medium. Living objects, medium. Bricks, medium. So basically, glass doors, windows, crowds, plants, and then walls. So this is all medium. This whole middle section is medium. And then the bottom section towards here, and I can't really highlight it, ceramics, high, tiles, concrete, high, walls, pillars, floors, stairs, metal, very high, elevators, cabinets. Yeah, so there are certain industries where this may be a commonality. So be aware in those industries, doing multi-cell may be very, very difficult. So in a pre-sale stage, this is definitely something, before moving forward with a project, you definitely want to understand if this is going to be a problem. If the venue has a lot of concrete and metal, then multi-cell, achieving a good multi-cell may be very, very difficult. Okay, so it looks like they just have some part numbers here. Okay, so let's see, site survey. So yeah, you want to have actually a floor plan, and it can be really simple. It could be just a piece of paper with boxes. The idea is you want to be able to draw out in radial circles as you move away from the base station. What is the attenuation? How, if we're near the base station, we'll probably be like a negative 24 or something in the 20s, negative something 20. As we start walking away from the base station, it'll go to negative 30s, then negative 40s, then negative 50s, negative 60s, and once we hit negative 70s, that's kind of where we're at the edge right there. At that point of time, we should go no further, because really, we need to think about headroom, because in most environments you will have a dynamic situation where objects, humans, merchandise, trucks, or whatever the industry or the venue is, may change the profile of the RF coverage quite a bit. Just keep in mind that element. I do have the site survey tool is very easy to use in the handsets. I do have a video that I show how to use it. So I would just put the handset in site survey mode, select the base station that you would attach to, and then go ahead, start the site survey with a floor map and just kind of in a circular radial fashion, kind of almost like a typographic map of a mountain or a hilly region on how they have the lines in kind of a circular fashion done. You'd want to do the same thing. If you've done any site surveys, it would basically be the same concept. Okay, so they're just giving us some general statements here. One base station can provide an indoor coverage radius of less than 50 meters or 164 feet, depending on a site map and the attenuation characteristics. Here, that is correct. We have a situation where there's really no items interfering or very minimal items interfering. This is kind of a general statement, but I would just be very cautious on, you definitely want to do a site survey, and you also want to leave yourself headroom. So if you're doing this for a customer, I would just educate them that, there's certain sections as you're doing the site survey where the signal strength is limited, and those sections at times might have issues with the connection. So that's just something you definitely want to notate if you're doing a site survey. Folks are aware, because if it's a retail store and they're bringing up different merchandise into the store and or changing their displays, perhaps they have stuff hung up on a wall, different type of items, and those items could be acting as different types of shrouds, if you will. If it's metallic, items made of metallic material, that can be, again, acting as a shroud, if you will, for the RF energy. So it says here DECT base stations must be placed in the center of an active working area in the building within line of sight. Yeah, so this would be the ideal. If you can place it in the center of the active working area and if you can have line of sight, that would be kind of the ideal situation. Obviously, often this may not be possible or realistic. So this is where you may need to do some experimenting. As I mentioned, you may want to have a ladder to be close to the elevation level where you would, plan to mount a DECT base station, and then you may want to kind of experiment positioning at different spots of the room to see if there's a certain positioning in the room where it may give better coverage to the adjacent areas or not. Okay, so this talks about the site survey tool. Okay, so this has a nice illustration of the DECT handset itself. Okay, and this just shows on how to get into the site survey mode. So we press the menu button, which would be right here. So if we see here, so it's going to be this key number 4 right here with the 3 horizontal lines. I know sometimes folks refer to this as a hamburger icon. So we would press this, and then once we press that, all we do is we type in *47*, and then this will give us a listing after a few seconds of the base stations it sees, and then we would select the appropriate base station we want to go and do a site survey with. So it's basically what they're showing here on this diagram. And then these are kind of the levels here. So this is if you're right next to the base station, we would be looking at a -24 dBm. So this is kind of what we're seeing here. So the way they have this position, excellent would be anything that would be -50 dBm or lower. So when they say greater than -50, what they're meaning going towards a 0. But in any case, when they say greater than -50, they mean like -49, -48, -40, -30, etc. Then very good is going to be -50 up to -70. And this is where I mentioned you typically don't want to go above -70 because you're getting into a gray area. Is it going to work? Is it not going to work? Is it going to have poor quality if the person turns around by 180 degrees and now they're between the actual DECT phone and the base station? They become now a new attenuation source. And is the call going to drop, or is the quality going to be so bad that they're not going to be able to understand what the other person's talking? So this is generally, if possible, my suggestion is to make sure that it's designed so we're not, going into the -70 range. And the same thing applies for the clock sync, RF clock sync between the base stations, because there may be inventory, different objects that are positioned at some point of time in the space that are now causing the attenuation to go higher to an area where it's not sustainable. It's going to have issues. Okay, the antennas are omnidirectional, as I mentioned earlier. Okay, so base station to be placed in the center of desired coverage area for optimal coverage. This again would be ideal, just like if you're doing a Wi-Fi deployment, but often this may not be possible, and you'll have to make some concessions of where the best position may be due to mechanical considerations as far as physically where it can be mounted. They do mention it should be mounted at least 2 meters, 6.5 feet above the floor. Obviously, if you look at this number, the idea here is to minimize attenuation from people walking. And in most spaces, you're not going to have items above 2 meters. Thus, the line of sight probability is much higher. Okay, installation caveats. Okay, so don't install the base stations on metal racks. That's correct. This not only can it cause attenuation, it can cause other anomalies. Do not install base station at the end of the room unless the desired coverage area is only at the end of the room. That makes sense. We want to kind of center it as much as possible. Do not install base station in basement floor or on table in basement and expect coverage on the first floor. Yeah, because there's going to be a lot of concrete, most likely, and steel, I-beams, depending on the building structure, and that's obviously going to cause a lot of attenuation. And there'll be other objects, If it's a machine shop and there's a lot of heavy, different type of machinery that's going on, then it's just going to be very, very heavy attenuation, and the performance is going to be very limited. Do not install base station behind a metal door, including elevator, if the coverage area is under the... Yeah, so yeah, definitely metal is going to be a high attenuating material. Do not place base station near high attenuation materials such as metal, concrete, as these reduce the RSSI value display. Yeah, so, you know, metal, concrete, those are definitely heavy attenuation materials. Do not place base station side electric boxes or closets. Yeah, this another attenuation. Just as a note, if you are testing in a lab and you're trying to test attenuation levels, this is something, if you have electric box or some type of other metallic container, you can use this to artificially cause attenuation to occur. So you can generate the needed environment so you can test roaming in a smaller area. So this could be used, you know, in a positive way for a small area testing. But here, of course, in a real deployment, yeah, we want to avoid that. So it says the base station must be clearly visible in a working area using the ceiling mount kits if the space is limited on walls or flat surfaces. The only thing I'll make a comment about mounting these on the ceiling of walls is just be aware, if you have to do any maintenance in the future, how difficult is it going to be to go up, you know, to reach it on a ceiling or a wall. If it's something you can just use a normal ladder and some, you know, ladder you have and you can get up there, then, you know, no big deal. If this is something that's really, really high up and it's going to be a problem to bring in the needed lifting equipment to get to that area, just keep in mind if there's any issues in the future, how big of a, you know, problem is it going to present to physically get to the unit if needed to get to the unit. Okay, so they talk about troubleshooting. In the admin guide corrects, you definitely want to, so both this is the deployment guide, but you also want to look at the admin guide. Let's see, rerun the sites, or after installing the base stations, rerun the sites to ensure you have good coverage. Yeah, so yeah, definitely once you have everything settled in, you would want to rerun a site survey. And if this is a venue that the profile changes quite a bit, if it's a convention center, airport or hospital, you know, it would be good if possible to run a site survey during normal operating hours, if possible, just to see what kind of impact, attenuation impact it has during operational hours. Because if you're doing a site survey and it's empty, the results you get might be quite different compared to when the venue is operational, full of people or merchandise or whatever other elements maybe during operating hours. Okay, let me see if there's anything else. Okay, so abbreviations. So probably the one that folks will ask most commonly about, what is this RSSI? It basically stands for Received Signal Strength Indication. So what is the signal strength that we're receiving? And it's typically listed in negative dBm. So if we're near the base station with the DECT handsets, will typically be in a negative 24, 25, 26, something in the mid-negative 20 dBm. As we walk further away from the base station, as we get to negative 70, that's when it starts, it's at the ragged edge at that point of time. And this is where you really need to be careful if the attenuation of the environment may change based upon if it's a venue that has people or has merchandise. So you just want to keep in mind regarding that. And let me see if there's anything else here regarding RF. Okay, so this talks about the firmware. Okay, so let's go back up in reverse and let me see if there's anything up here. So this talks about the history, revision history. So be aware, a lot of this documentation does get updated. So when you're viewing this, there may be newer updates compared to what I show here. Yeah, so just keep in mind the goal of this guide is to basically give you a pathway of your deployment to minimize issue, and also if you open up a case with Cisco TAC, this is kind of what they're going to be leveraging as a reference for supporting different type of deployments. And I'm just seeing if there's anything. So for industrial deployments, often you'll see folks use the ruggedized version of the handset. Okay, we talked about the site survey, asterisk 47 asterisk. Okay, this is what I was mentioning earlier, 1920 to 1913 megahertz in US and Canada. Other regions of the world, it's slightly different, like Australia, New Zealand. It's 1880 to 1900 megahertz. EU and APAC, 1818 to 1900 megahertz. I don't have any comments about the other regions like Australia, New Zealand, EU, and APAC. But for the US, I can tell you the closest thing that is most noticeable as far as RF spectrum usage goes is GSM 1900. So most environments you will see energy at GSM 1900, which is near this. So far, I've not run into a situation where that's been an issue. But just kind of be aware, if you do have a spectrum analyzer and you fire it up, when you're looking at the energy around the 1900 megahertz area, because normally it'll be you'll select the actual width of the spectrum you want to look at, and what you will notice is you'll notice a section where it has this constant energy. Just be conscious that most likely if you're seeing this constant spike of energy near this area, most likely it's GSM, and what you're seeing is most likely not DECT. The DECT, the way it shows up, it'll just pop up momentarily, then it'll disappear. And the sampling rate of the spectrum analyzer needs to be quite high. But in any case, so 1920, 1930 is for US and Canada. DECT uses a combination of frequency division multiplexing, time division multiplexing, time slots. And this is where I mentioned seeing it, unless you have a high sampling spectrum analyzer, it might be a little bit tricky. DECT devices share available channels on the radio spectrum and limit the active number of devices within close range. Yeah, so it is a very clever technology in general. So if you do have access to equipment that has high enough sampling rate that is able to cover the 1900, specifically 1920 to 1930 megahertz RF spectrum, such as a spectrum analyzer, something definitely I would suggest you do some testing and studying in your lab before doing a project at a site, just in case you do run into any oddities. You can pull out the spectrum analyzer and do a comparative analysis to what you're seeing on site. Okay, so this mentions base stations register with call control system upgrade for immediate. Okay, so this is more for WebEx calling. So as of right now that I'm recording this video, it is true when you onboard the base station to WebEx calling, the firmware is updated. If the base station has very old firmware and it's for some reason not upgrading, I do have some videos to show how you can manually upgrade the firmware to kind of help it along if it's getting stuck. At the recording of this video, if you're deploying this with CUCM, Cisco Unified Call Manager, there is no firmware pushing from Cisco Call Manager to the DECT base stations, because the DECT base station at this point of time is a third-party SIP device advanced, so you do manually have to update the firmware using a local TFTP app or server on a PC. I do show the steps. I have a couple different videos I've created over the years that show the step. It is critical that you update the firmware on the base station before you attempt, and the handsets before you attempt to use it with CUCM. Otherwise, you will run into issues. So at the time of the recording of this video, you want to make sure you're at firmware 5.1.2. I believe SR1 right now is offered. So you want to make sure you have the latest firmware both on the DECT base station and handsets before you start using it with CUCM. Okay, we talked about simple site survey tool that the handsets have. And it is very easy to use. If you mount the base stations behind closed doors and between steel beams, it creates a signal interference which leads to reduced range and reduced coverage. Yeah, ships and other venues where the doors are made out of thick steel, when you close the door, basically the signal level goes down to zero. Or nothing that's really measurable, that's usable, I should state. So be aware this can make a huge difference. And this is really, the site survey is very, very critical. Even if it's a pre-sale stage, and if you're a Cisco partner, this may be a service that you may want to offer a client that's doing a site survey, coming on site with a couple DBS-210s, some ladders, and doing a site survey and just kind of figuring out what is the potential coverage area and how many base stations may be needed, et cetera, et cetera. Also, as I noted, analyzing the network, seeing if there's any issues regarding multicast and IGMP snooping version 1 would be another consideration, be part of the site survey, just to make sure you have all your bases covered. And again, having couple DBS-210s, at least I would say 2 for site surveys, so we can validate that the multi-cell can function. Having 3 would be nicer, but you would need to kind of determine what is optimal and realistic, because if you're a single person, obviously that's going to limit on how many base stations concurrently you want to have to deal with. See if there's anything else before we wrap up this video here. Okay, so there's just some planning tips here. The area to be covered, yeah. So you definitely want to get a floor plan for the facility manager, the FM, or the client that you're working with, so you kind of understand what they're trying to cover. Type or architecture of building and typology, and so on, includes material, thickness of walls. Yeah, so this might be a little bit tricky depending on who the client is and what venue it is. If it's industrial, then pretty much, metal and concrete is going to be something that most likely you're going to run into. And propagation is going to be quite limited. So that's where you're going to have to get creative on positioning and how many base stations you'll need, et cetera, et cetera. Be aware that if it's, as I mentioned earlier, if it's industries that are using equipment that may generate high levels of RFI or AMI energy, and or may introduce harmonics due to the high levels of energy they may be generating, those are all potential items to notate and make sure the client is aware that those can be interferers during different points of the day or whatever they may be doing at that venue. Okay, so you don't know the required precise knowledge about the makeup of the thickness of walls. You should be aware the interior grade and exterior grade walls. Site survey tool helps determine. Yeah, it is true. There are sections of the building inside, at least the region I am at, like United States, there are a section of the buildings indoors which have to be firewall rated. So not only the walls, but also the doors, and the walls have to go all the way up to the floor, ceiling, I should say, above. Those tend to be thicker materials, and there will be higher levels of attenuation. So that's where you may see a noticeable difference, where certain parts of the building, the amount of propagation or signal strength you can get through walls will be quite different compared to other parts of the building, and that could be definitely attributed to the fire codes and the firewall and fire door ratings that you may see in the buildings. Estimated traffic in a coverage area, okay. Any signal obstacles located in each coverage area, any new Ethernet cables, power outlets required to support. Yeah, so that definitely, if this is going to be mounted in a really isolated area where there is really no equipment there, obviously, you'd want to leverage PoE, so that would be obvious. And then the other thing is going to be distance. Is 100 meters or 328 feet long enough for that area? Because there are venues or very large warehouses or stadiums or other shipping yards, very airports, venues where there's areas where they may want coverage, but there's really nothing nearby, at least that you can do with an Ethernet for PoE. So you may need to do fiber extenders, and they may need to have some type of power for those fiber extenders. And then from that point on, you may need to have a PoE injector to get that last leg over to the to the base station. But most likely for those venues, this will not be the first application where the customers run across that. IP cameras have been used for a very long time. They've been introduced in the early 2000s, and those are key items in larger venues like airports, shipping yards, stadiums have because of security and other reasons. Okay, intended number of handsets simultaneously registered. There are some considerations as far as deployment capacities. I don't know if they mentioned in this guide. Let me see if there's any statements in this guide, but definitely in the user admin guide it is mentioned, and also in the data sheet. Okay, so yeah, so there's a chart right here. Single cell deployments, number of registrations, concurrent narrowband calls, and then concurrent secure narrowband calls, concurrent secure wideband calls, maximum number of repeaters that may be connected to systems. So this is assuming we have a single cell deployment, and then dual cell deployment, and then this one is multi-cell. So most likely you're viewing this video because you're doing a multi-cell deployment. So let's see, multi-cells can have 3 to 254 base stations where the radio signals overlap for seam handover. For multi-cell systems, we recommend LAN synchronization. The following table explains support for handsets and concurrent calls. Okay, so this is for DBS-210, this chart towards the bottom. Number of SIP registrations with 250 base stations is 1,000. Concurrent narrowband calls for 250 base stations is 2,032. Concurrent secure narrowband calls is the same number, 2,032. Concurrent secure wideband calls to 250 base station, that drops basically by half, 1,016. And maximum repeaters that may be connected to the system is 100. The repeaters, be aware, there's really no management of the repeaters per se, in a sense that you're adding it as a device kind of in the middle. There's some limitations, so I really would recommend not focusing towards repeaters who are doing multi-cell. I would just stick with the DBS-210s. Just from a robustness troubleshooting standpoint, that's a better way to go. But of course, there may be situations you have no choice. So definitely look at the admin guide details for the repeater, just so you understand what are some of the limitations with that. And then DECT synchronization. If you're doing this deployment with WebEx calling, it is by default air synchronization, and there is no setting in Control Hub as of the recording of this video to make any such adjustments. So if you're having issues with air synchronization, or you're doing a site survey and you're realizing air synchronization is not going to work out, you will need to open up a case with Cisco TAC and discuss this with them and figure out, what options there is to do the LAN synchronization. If you're doing this with CUCM, you have full admin access to the base stations. One thing I should mention here is you do not have admin access to base stations when this is deployed on WebEx calling. So what I've been showing you assumes that you have opened up a ticket with Cisco TAC and they've created a temp admin password for troubleshooting reasons. Otherwise, you don't have accessibility to view and generate a lot of stuff I've been showing this video. So just please note, this is if you're doing it with WebEx calling, and the time of the recording of this video, that's how it is. For troubleshooting purposes, again, open up a case with Cisco TAC. What they're going to ask for is going to be the MAC address of the first base station deployed, and what was the user that their first base station was deployed to, the name of the DECT network, the org ID, and the site name. So you want to provide those components to Cisco TAC in an effort they can work on the back end to be able to create a temp admin user password for the troubleshooting efforts. If this is with CUCM, then it's really your discretion. You have full admin access, and it's really your discretion if you want to do the LAN synchronization. Be aware the LAN synchronization is PTP-v2, also known as IEEE 1588, and there is additional considerations you need to make if you're going to be using PTP-v2. Let's see, multi-cell system is mostly used in medium business that have large coverage areas with many users. DBS-210 is the only option for multi-cell. That is correct. So at the time of recording of this video, the DBS-210 is the only option for multi-cell deployments. Okay, so let's see if there's anything else here. Okay, so they just mentioned here single cell setup for small area with low density, correct. Otherwise set up multi-cell, correct. Typically small retail store can have a single cell system. You must confirm this with a site survey. That is correct. If the store is open area without real radio signal barriers, one base station cover. Yeah, so this is correct. This is a small typical store that generally with the 1920 to 1930 megahertz, it generally has fairly decent propagation, assuming, no concrete walls, no steel, barriers, etc., which generally in retail stores, other than maybe just the general structure of the building, if it's a seismic zone, other than that, generally you'll have pretty good performance for a small storefront with a single base station, but you do want to verify or validate that via site survey. Range of the base station is 50 meters, which we talked about, 164 feet radius in a building, so indoors in a building, made of standard brick or mortar construction with basic interference from low-level shelving and other items found in retail store or workplace. When you move away from base station, the signal degrades from good, weak, poor to no signal. That is correct. So this is kind of, once you start getting into this orange area, that's where you kind of have to put some limitations. And so I look at it from like a -70. Once you start getting to -70 dBm or higher, that's kind of where you should kind of put limitations on. Okay, let me go ahead and end the video right now. I will post the link for this deployment guide document and any other useful information that's available at this point of time in the description below. Hopefully this gives you some direction regarding if you are having issues with multi-cell DBS-210 DECT deployment, what information needs to be gathered for Cisco TAC. So if you're working with them, and then also if this is a pre-deployment stage and you want to consider, things you should consider, I should say, as far as site survey, documentation to look at, and other RF considerations. Hopefully this video helps you with those objectives. Thank you for watching the video.